Hello, YouTube learners, students, and friends. This is Dr. Satish Singhal, PhD, again, Professor of Computer Science at Camino College, Torrance, California. In this video, I'm just going to show you procedure. Procedure is not tied to any particular algorithm or data structure. It is just kind of a mental picture of what an algorithm should be doing. So I'm just going to show a procedure to convert hexadecimal to decimal. There will not be any code in it. It's just statement of what later an algorithm should be doing. Okay, so let's look at it. So in this procedure, we will convert a hexadecimal number 1F41. We can tell it's hexadecimal because it has a letter F in it. Anytime you see letter A, B, C, D, or F in a number, you can easily tell it's a hexadecimal number. And I'll tell you right now, in decimal system, it will be 8001. And understand that there may be many algorithms and data structure used that may allow us to do that. And our actual C code may use data structures such as array to facilitate the whole process. That would actually be shown in video number 3 and then in 4. But for now, we show the whole procedure schematically below. So what we do is we assign a positional number to each digit starting from the extreme right and moving towards left. So rightmost digit would have positional number 0 and 1 to its left as position number 1 and so on. We show that as follows for the hex digit 1F41. So notice 1F41. So index of the location of each digit, this is 0, position number for that is considered 0. They go left to right, right to left, sorry. And for 4, it's 1. For F, it's 2. And for 1, it's 3. Don't get confused between 1 and 3. And this is the number, these are their index of location or position number. Okay. Next, we find out that what is the weight of each digit when we change to decimal system. And this is done by multiplying decimal value of each hex digit by 16 to the power of positional number on that digit. And we show that in the table for this number 1F41 that you saw before, and table is right here. Important to understand this one. So these were the positional number 0 for this, 1 for this, 2 for this, 3 for this. Number is 1F41. So what we do is we take the digit and multiply 16 to the power the position number. Of course, 16, anything to the power 0 is always 1. So contribution of that digit would be simply 1. 1 multiplied by 1. Then we take the next digit and its position number, which is 4. So that'll get multiplied by 16 to the power 1. Why 16? Because hexadecimal system has 16 digits. So we use 16 power. And that'll compute to 64. Then position number is 2. Digit is 15. Value of 15 in decimal is, sorry, is F. I'm jumping ahead of myself. F, value of F is, in decimal is 15. So here we multiply 15 into 16 to the power 2. 16 to the power is 2 is 256. Multiplication of these two comes to 3840. Okay, and then position number is 3, digit is 1, so we do 1 into 16 to the power 3, and that comes to 4096. Okay, and our last step would be adding all these numbers in the bottom row to get the conversion of 1F41 to decimal, and we just show that right here. If I add 4096, I'll make that visible as well. A little hard, almost. 4096 plus 3840 plus 64 plus 1 will come to 8001. The number 1F41 in decimal will be 8001. Okay, and that's the summary again, which you saw. I already described how we get these, and then we add them all together to get the conversion of 1F41 to decimal system will be 8001. Okay, so that's the procedure. Next we have to find an algorithm in a language so that later on that could be converted into source code of that language. And once we have the source code, we can run this test and make sure all the results are coming out right. So notice how in software development we have these stages which cannot be skipped. First, we have a statement of a problem. We try to understand the problem, like we understood what hexadecimal numbers are. Then a procedure, if you want to convert them to decimal, what is the procedure? We got a procedure which has some of the math and other things. Next thing we're going to do is use the algorithm in a language. So algorithm is like a pseudocode. It's actually not a code. And some of the linguistic language elements will be there. And finally, we take that algorithm and we convert into source code, which is compiled, tested, and run. Okay, so in next video, I'll show you how we use a C language algorithm to accomplish this conversion. Okay, all right, see you in the next video, number 3.